Alright, welcome to this next video, guys. Going to be talking about multiple events for this one, and our learning goal is that you can determine the probability of experiments with multiple events. And at the end of this sort of section, you want to be able to construct a table to determine the sample space and can calculate the probability where multiple events are happening. Alright, arrays of probability. You've already probably been looking at the idea of, right, what's the probability if we're rolling a six-sided die? Our sample space is going to be equal to 1, 2, 3, 4, 5, and 6. And that's pretty easy to deal with. But what happens if we're rolling a six-sided die and a 100-sided die at the same time? So that's going to cause issues. Like, what's the probability of rolling one on the other, and like a 5 on the six-sided die and a prime number on the 100-sided die? That's going to cause some issues. So what we can do is we end up being able to multiply the Cartesian product of these two sample spaces. So maybe sample this way, and we're going to call the other one V, I guess, equals, so new sample space. So 1, 2, 3, all the way down to 99, 100, and then these sort of get multiplied against each other, and you end up creating this array of probability table here that you can sort of select from and see all the new outcomes that are possible from these two different sample spaces. But we can go even further than that, is that when you add extra ones in, you're just sort of like multiplying another sample space into that. Now, it does get limited because we can't just go, all right, let's just make a three-dimensional one where down this one we've got when we're rolling a 8-sided die, 1, 2, 3, 4, etc. So it's going to be hard to deal with the volume of probability. And then what happens if you've got 4 different things? So the tables are good, but they do have limitations, and so it mainly works really for just 2 separate events, okay? Or 2 events sort of happening together in an experiment. So let's have a look at some of the different things. All right, our key ideas is that these things called multiple event trials have more than one component to them. You're not just rolling a die, you're rolling a die and maybe a color wheel or something. There's just 2 things operating together or more. They can be also called compound or multi-stage, depending upon sort of the question, the textbook, or that kind of thing, okay? So as I sort of showed you before, the different probabilities can be multiplied. It's actually something called a Cartesian product, where you sort of like matching one with one, etc., to create this thing called an array. Now the different outcomes in the table, this is important, they're ordered pairs, and so they need to be listed in order so that the outcome AB, for example, is different to BA. This is similar to our XY stuff, where if you're talking about this point here, it would have some X value, some Y value, and the order made sense that everyone knew what we're talking about, okay? Right, let's have a look at an example to sort of show you how this works. So flipping a coin and rolling a die. So the first thing you do is you construct a table up where the top sort of columns, headings are the sample space of one of them. So this you can see here is the sample space for, that's the worst giant curly bracket I've ever drawn. This is for rolling a die. This is the sample space there. And this one here is the sample space for tossing a coin. Okay, now we're going to do the Cartesian products of these two. So this first one here, let's go with, we're rolling a die first and then we're flipping a coin second, so that we can kind of help ourselves stay with the order correctly. Okay, so we're going to go 1, heads. So this one is going to be 2, heads. Okay, so this is the event of rolling, so the outcome, sorry, of rolling a 2 and then a heads. This is rolling a 3 heads. This is rolling a 4 and a heads. This is rolling a 5 and a heads. Oops. And this is rolling a 6 and a heads. My H's are looking like 4s. Now this one here, we're moving on to tails. So it's still our numbers: 1 and a tails, 2 and a tails, 3 and a tails, 4 and a tails, 5 and a tails, and 6 and a tails. Okay, so now we've populated our probability array. Now we can kind of use it. All of these things here are the separate events, all right? So we can sort of state now that the total number of trials or events, sorry, outcomes, outcomes is equal to 12 in this case. Okay, so with our favourable over total, that's our number that's going to go on the bottom there. Okay, so the total number that you've sort of got in this array here. All right, let's have a look at some questions. So let's say we're asked to find the probability of rolling a 3 and a heads. Okay, and so we would say our favourable over total, and we have a look. Right, when do we roll a 3 and a heads? Oh, here's the only time that happens. Okay, so there is one favourable outcome over the 12 total favourable outcomes. There's our probability. Okay, let's say we're going for something a little bit more complex. I'm going to go the probability of rolling an even number and flipping a tails. So write our formula, favourable over total. And let's have a look. Let's see. Okay, so our favourable outcome for the evens is here, here, and here. Our favourable for tails is here. Now, so wherever these intersect, that's where we got. So this one, and this one. There's our three possible outcomes where that's favourable. So that's 3 favourable divided by the 12 total. And that can be simplified to a quarter. So a quarter of the time, we'll roll an even number and tails at the same time. Okay, so hopefully that's landed well for you. I'm trying to make these probability ones short and snappy if I can. So please let me know straight away if there's something you don't really understand, and I'll catch you at school. Thanks.